have the Wheatstone Bridge experiment to be our experiment 5. So today we'll be having again, we have different apparatus that will be implementing in the Wheatstone Bridge experiment. The aim of the experiment is what to basically determine unknown resistance of a particular resistor. The resistor will be given to us, we'll measure it, and then we'll also calculate the resistance. Alright? The apparatus we have how many of them? We have the DC supply. This time around is a static DC supply. 3 volts, meant only for the Wheatstone Bridge experiment. We have the big DC supply that has up to 25, 30 volts. We have the big one here, but we have a very smaller one that is just meant for this experiment, which is 3 volts as the input, as the V in. 3 volts. The DC supply is 3 volts. We have the connecting cables as usual. 2 resistors will be given to you. It will be on the Wheatstone Bridge connection box. The galvanometer, which looks like a meter stick, will be given to you as well. Then your digital multimeter. Now, this is a very interesting circuit diagram that we are going to be looking at today. The circuit diagram, of course, comprises of the 2 resistors. We have the Rx, which is the unknown resistor. Okay? And then we have the known. Now we have the galvanometer, which is the G here. And then we have the stick, the galvanometer's length from 0 to 50. That's the measurement of the galvanometer. We have 0 to 50. We have 0 to 50 here, 0 to 50 here, and then 50, of course 50.01 down to 100. All of them calibrated is 100 centimeters. The calibration is in centimeters. So from here, 0 to 100 centimeters, 0 to 100 centimeters. Half of it is your L1 and the other part is your L2. Now basically what we're trying to try out here, we're going to ensure that at this point we're going to be having a zero. The current will be, as the excitation state of this galvanometer, we get to 0. Okay, so we have the direction of the flow of current, which will go in through Rx and then R. Now, for the fact that we have this connection here, which is the positive and negative, we can actually still, in case this will confuse you, we can actually still carry it because this is a closed circuit, okay, where we have, in this closed circuit, we now have these 2 terminals connected to the positive and negative terminals of your DC supply, which is 3 volts. Now, in any case, if this is going to be confusing, this can also be brought down here, which is something like this, which is something like this. When you have the galvanometer here again, you have an Rx, and then you have your R. Again, still you can see that the flow of current is still from the positive to negative. No need to indicate, you can still indicate here now that you have it down here, but there is no need because this is actually a closed circuit where you have the circuit elements interconnected together. We still have the L1 here, and then we have the L2 at that point. Alright? So, having said this, again, we have the equations that we are going to be making use of. You have the equations here. This is your equation. Now, you have the Rx divided by R equal to L1, of course, which is part of the length of the galvanometer, divided by L2. Your known resistance again, you know, is Rx. Then we have the R. The R, of course, is your known resistance. This is known resistance, yes. Known resistance. This is your unknown resistance. So equal to, because we need to make Rx the subject of the formula, your known resistance. So here we have R divided multiplied by L1, okay, divided by L2, all right, equal to R, which is the known resistance, multiplied by the whole of L1 divided by L2. So this is a very simple table. Very simple table for you to, of course, comprehend. Very simple. Where you have the L1 measured in centimeters, not in meters, please. Centimeters, alright? And then you have your, of course, the L1 and L2. Then you have your resistors. The resistors will be in ohms. Your resistors will be in ohms. Okay, so we have the measure and then the calculated. Again, like I said before, we need to measure the resistance and then we also need to calculate the resistance. Okay? Then your values will be here and that's it. Remember that the current is, when the current is 0, is the excitation state of the experiment there. So we are going to carry out the experiment here. The connection is quite easy. The connection is quite straightforward, quite easy. We're going to do the connection and then we'll start sliding this. We'll start sliding the wire, going back and forth on these slide wires until we get to a certain point where it is 0. Okay? And on your digital multimeter, because you're going to do the connections and then do the connection, which is, of course, which is the positive and negative terminals. Put it in the digital multimeter, and then it will be reading while you're sliding, going back and forth the slide wire on the galvanometer. Okay? At that point where you see 0, you then measure. You now check. Where has it stopped? Is it at the L1 part or the L2 part? And then you can now determine L2 if there is an L1. And of course, you also know your R, which is your known resistance. So, first and foremost, what do we measure? We measure what? The resistance, which is R. One of the resistances, which is R, which is the known resistor. We need to measure it. This is it. We take it out from the WHEATSTONE Bridge connection box and we measure. Alright? So let's do this real quick. Of course, you know how to measure already. Very simple. We already know how to do the measurements. Let me just get one connecting cable here. Again, that's your multimeter. You connect. Where are we going to connect it? Is it 20A, MA, voltage, or which one? Where? No, for resistance. Are we connecting it in V? Because we have V, ohms, hertz. Is it in com or MA or A? Where? Which of them? Ohms, right? Which is the V here, the positive one here. And then the other one is where? The next one, which is the COM port, the black one. Good. What are you? What we have? Tell me. 32.6. Alright, thank you. So we put it there, and you see the measured. Remember, the measured value. Measured value. So we put it there. 32.6. 32.6. 2 decimal places. 60. 2 decimal places. Don't give me 32.6. Give me 32.60. Alright? Good. Then we carry out our measurement now. So here we start connecting. Look very closely. We'll start our connection now. First and foremost, we need to get this guy. The terminals of the galvanometer will connect together, okay? Now, this is the WHEATSTONE connection bolt. WHEATSTONE bridge connection bolt. Now, you can see that the galvanometer, are you seeing the galvanometer, something like a meter stick there? All of them interconnected. Are you seeing a meter stick there? Where you see L1 and L2. Are you seeing it? can see that, right? You can see it. Now, it shows us that that's one of the points, right? So you put it here. Cool. You don't want to spoil it. And the other one, I think we need to take a longer cable. I don't trust the flaps. Yep. Sorry? This one, yes, the WHEATSTONE Bridge. Really? The whole of it. The whole of it is this. The whole of it is this. That's one. See, that's the WHEATSTONE Bridge experiment. You can see the connection already on this board. It's the WHEATSTONE Bridge connection board. You get? So these ones are the Apparatus standard. We're just trying to replicate what's on this board. You get? And this is like I understand where it's coming from. Should we add? Let's add the WHEATSTONE Bridge connection box. Something like that. Thank you for that WHEATSTONE Bridge connection box. Okay? Let's put it that way. Right, so we look, forget about writing first. Let's concentrate on this. See, we've done the connection for these guys, right? Then, what else? So you have the green here, right? You see that this green is here, right? I can see it's in the middle of that galvanometer. This guy. You can see that. So we checked. I think a green cable is better for us. So we have a green cable here. See that? Now the next one is your positive, as you can see, as a black and red here. Obviously, they've told us that it's the. What's this one for? What's it for? These two. What are they for? Thank you very much. Even if it's one person that says something, the person is here. And the person can go to the rectory building and say, yes, he taught us something. Yes. It cannot be everybody that understands. But if you don't understand, see, this one is playing on my chair. You see? If you don't understand, don't hesitate to let me know. Come on. Ascend. Now, we connect again. So we get a black cable. Easier for us. Is there a longer one? Yes, there is a longer. There's a longer one. Black, right? The power supply has already been. This is the power supply. Let me show it to you. This is the power supply. You can see. You can see that, right? Dedicated power supply for this experiment. Dedicated. This one is also, but we don't want to use it. We have a special one for this. So it's even upside down. Alright, so then we have the positive. The connections can be, it's very simple, but I mean the cables are not, sorry. What else is left? No, we've connected the power supply, which is this. This one now that is left, these two. Now, you can see that both ends of this resistors are connected, right? Even in there, you see one end. Each of their ends are connected. That's why we have it here. And of course, the other ends are not connected. You can see that's why they're not. So we need to actually take this one here now. You can see. Tell me, as a green. So it's been connected already as it stands to this one here. Now, good. You see that? So what are we going to do now? We're going to put a cable here, which will be what? This cable, as you can see, is black. I mean, there's a line here, so it's black. So this black one will go to our negative terminal of the COM port of the multimeter, and this one here will now be positive. Because we need to measure, right? So these are the measuring terminals for us to put on our multimeter. You get it? So we need a longer cable for the power supply. Okay. Then so MA again, because the current is still in MA. Just like I explained already, because I cannot. Okay, so you can see that negative, both ends that have the black is telling us we need to connect it there. And then the other one here is to the positive. So the connection is complete. The connection on this board, as you can see, is completed here. That's why it's the WHEATSTONE Bridge connection box. You see? Now, because when we're connecting all these things, it's still on top of this guy. So there's a circuit board actually inside, embedded in this guy. Because we have the resistors connected there. And of course, the terminals of the galvanometer still connected. Now we turn it on. Let's be sure what we get. Sorry, you take it to A. That's your, where is it? Milliamperes. Alright, milliamperes 20. This one is already on, turned on. The power supply automatically is turned on. Yeah. Oh, okay, yeah. The power supply is automatically turned on already. So we need to start adjusting. We don't have any. Let's change this guy. We have one. So we've done the connection. Now let's start sliding back and forth. Now first off, let's measure this resistance for the no resistor again, because we changed it. I want to change it. If we measure it, let's measure. We're going to change it from 32.60 that we got. We need to change it. What I have 0.08. So remember, it's in ohms. This one is in kilo ohms. What it gave us is kilo ohms. So if you convert to ohms, what I get? 80. 2 decimal places, 80 kilo ohms. 80 ohms. All right. So we put it. Now let us carry out our measurement. So here we turn it on. So come on, tell me what you are seeing. Almost.
0.6, 0.5, 0.04.
Okay. Minus now, so we 0.02, we move it again. 0.01, let's move it again. Okay. 0. Alright, finally. Thank you. So, we've gotten to the excitation state of the Wheatstone Bridge. Okay, so we measure it, that's the connection. So we check line of sight. Yeah, good. Line of sight, please. Line of sight on the galvanometer we measure. So what are we seeing? 44.49. 44.90. 44.90, please. 44.90. Because after the 44.90, you get 45. So, where is it? Now, 44.90, is it in L1 or L2? L1, very good. So, 44.90. That's why I said 2 decimal places. Now, if you do your calculation, remember your calculation should be at that point. I'm going to do it down here. You should put it in your calculation section. So, using what? This. To calculate for your L2, because we need to find L2, right? L1 plus L2 is equal to 100 cm. L1 is 44.90 plus L2 is equal to 100 centimeters. Therefore, to make L2 dissolve, the formula is minus 44.9 all in cm. Tell me, calculate with, give me calculator. Calculator, don't use your brain. I know you guys are very intelligent. But give me the value you get from the calculator. 55.1. 50 what? 55.10. Yeah. So 55.10. Now, remember your measured. We are going to measure for Rx, right? We measure it, take it out to measure, just like we measure the resistance for the known resistor. So this time around, I'm going to use what? This formula. This one, which is this, equivalent to this. This is equivalent to this. So your Rx is, remember you need to do it very well. What's your R? 80, right? Multiplied by, what's your L1? 44.90 divided by 55.10. Do this first. Do this one first.
0.81.
0.81. Alright, so 80 multiplied by 0.81, what do you get? 64.80, right? Right?
Yes.
Now, is it in ohms or kilo ohms? Tell me.
Ohms.
Good, nice. Your brains are here now. Ohms. So you put it where? Here or here? Calculated, very good. 64.80. Now, our table is almost complete. So we measure what? What are we going to measure now? The Rx. So you take it out from here. Remember, you turn this guy off. Take it out from the Wheatstone bridge connection box, and then you measure the resistance. Okay. Now to do that already, right? So after the connection there, what I have? 0.09. Good. So put it back. So if you convert, can you convert to ohms? So you see, this one almost closed, yes, but this is calculated for this, and so it's the difference is like 20 point something or thereabout, because if you minus this one, it's going to be 20 point something. Okay? So most of the time, of course, you saw the battle we faced when we were trying to do read from multimeter. So most times the errors can be from the multimeter, even from the power supply, of course, because it was a bit having some partial contacts initially, and from other apparatus that we may have. So, but nonetheless, it should be close to what you already have. If we're having something like, say, maybe 100 or maybe 200, that is a very big problem. Or even, I say 100 and something, it would have been a problem. Okay, but still, we are still close, and then we're able to see the excitation state of this Wheatstone bridge, which got to 0. Okay, and we measured it. Any questions? So that's just it. Of course, this calculation should be in your calculation section, and then that's the table. Quite simple. Any questions?